Hello, this is Lesson 1, Unit 1, Launch, Explore, Discuss. So we're just going to talk about what you could have missed if you were not in class today, or if you need a review, what is it that we talked about in class today. So in the jump start, we looked at this tile as if it was tile on the floor. And the question was very simple. How many green tiles are there? Now, if we count them one at a time, 1, 2, 3, 4, 5, 6, etc., we're going to find that there are 28 tiles. But really, the question is, how can we group them in such a way that not only does it make it easy to count, but also, if we change the size, then how does this number adjust? So there are many ways to do this, as we pointed out in class. Let me just show you a few of the ways. One way is to kind of draw a diagonal through here and look at each side as separate. And then you have 1, 2, 3, 4, 5, 6, 7. You have 7 in each of the 4 groups. So 7, 7, 7, 7, all the way around. And that's 7 times 4, that's 28. Another way to do it would be to look at including one of the corners like this. Oops, a little too far. Let me do this in a highlighter, it'll be a little easier to see. So we're going to include one of the corners here and say that's a group. And let's darken this a bit. Okay, so then we go down here like this. And here's another group. And then we'll include that corner, and here's another group. And then finally we'll include this corner, here's another group. So how many are in each group? 1, 2, 3, 4, 5, 6, 7. And again, there's 4 groups. There is a way to do it where you're looking at 7 groups of 4. There were some people that discovered this today, and that would be looking at groups of 4 like this, all the way around. And they found that there were 7 groups of 4. The way that I showed you was, if we took these corners and we separated them off, then each corner has 2 shaded tiles. So that right there is a total of 8. And then if we look at what's left on each side, there are 5 in each side. Now that's significant because the inside square is a 5 by 5 square. So what we pointed out today was that on these side ones, like here, the number of green squares is exactly equal to the side of the square. And in that case, we would do 5 times 4, because there's 4 as you go around. So there's 8 in the corners and 20 on the sides. Now, it's important to be able to extend your pattern, because what if we change our mind? What if we want a 6 by 6 or a 7 by 7? So down here in this problem, number 1 said find the number of colored tiles using a strategy either you or one of your peers used. So let's use that same strategy where we take the corners, and there are 4, and each one has 2 tiles in it. So that's a total of 8. And then we've got this group. Let's see, did I go down far enough? No. This group, and finally the 4th group. How many are in each of those 4 groups on the side? Well, again, this is a 6 by 6 square on the inside. And so whatever side length that is, 6, that's how many squares, how many green squares go on each of those sides. So 4 groups of 6 and 4 groups of 2, making you have 24 and 8 more for a total of 32. So now what we raised in class was, well, what if you wanted any size? Like, for say a customer says, I want size 12. I want a 12 by 12 square in the middle. Can you quickly come up with the number of green squares? So in this problem number 2, we're now replacing a number with a letter. And so instead of saying it's a 5 by 5 or 6 by 6, now it's n by n. And so we still have these corners. If we continue with this method, we still have 8 in the corners. 2 and 2 and 2 and 2. But then on these sides, see, they didn't fill in all the squares because it's unknown how many would be there. Until the customer tells us, we don't know how many go there. So you can't just count these green ones and say, oh, there's 1, 2, 3 of them. Or there's 4 of them. We don't know how many of them. But we do know how many of them are, because whatever was the size of the square, that was the number. So let me go back and show you on these previous 2 examples. When we had a 5 by 5 square, it was 5. And 5 was repeated 4 times. When it was a 6 by 6 square, 6 was repeated 4 times. So think about it. If it's an n by n square, that's right here, n by n, then how many are in each of these 4 places? Well, there'd be n here, n over here in this group, n down here in this group, and n over here. How many n's? Well, what's the same as n plus n plus n plus another n? Isn't that a total of 4 n's? Or 4 times whatever that number is. Plus, don't forget the ones in the corners. So 4n plus 8. One question I asked in my class. Okay, let's say the customer orders a 100 by 100 size inner square. How many green ones would that be? Well, substituting, evaluating, that would be 4 times 100 plus 8. There would be 408. So this is the formula that will always generate the number of green squares. That's what we're going to build on for our next unit. Now, just in case you went on in your class to the Ready for More section, let's see how this would work. Well, again, whatever the width is, that's how many tiles you're going to have up here. Whatever the length is, that's how many tiles you're going to have up here. But you're actually going to have double that, because whatever there is on top, there is on the bottom. Whatever there is on the right side, there is on the left side, side to side, up and down. And then, of course, the 4 corners are always going to be 8. So plus 8 for that, you would have 2 times the width and 2 times the length. So in this one, you have to have 2 letters, because you have 2 distances or shapes, numbers that are affecting the shape, the width and the length. So the strategies, that really your takeaway is trying to break things up in groups of equal size. Groups of equal size. And you're going to see that in our Ready, Set, Go section, which is following this one. So that's the next video. Have a good evening.